Hello everyone and welcome to our presentation. Today we are going to talk about one of the most important ideas in calculus, the derivative. This concept plays a major role in mathematics, science, engineering, and even in everyday life. Together we will explore that the derivative is, how it is defined, and how the derivative theorem helps us calculate derivatives in a much easier way. My name is Sarah, and I will be presenting the first part. Derivative theorem. The derivative theorem refers to the collection of rules that allow us to compute derivatives easily. Instead of using the limit definition every time, we can add the formulas that simplify the process. These rules include power rule. The power rule says that to differentiate x to the n, you multiply by the exponent and subtract 1 from it. Constant rule. The constant rule says that the derivative of any constant number is zero. Product rule. The product rule says that the differentiate two functions multiplied together, you differentiate one and keep the other, then switch. Quotient rule. The quotient rule says bottom times derivative of top minus top times derivative of bottom over bottom squared. Chain rule. The chain rule is used when one function is inside another. Differentiate the outside, then multiply the derivative of the inside. Thanks to these rules, we can differentiate complex functions efficiently, which is extremely useful in physics, chemistry, biology, economics, and many other areas. In this presentation, we learned that the derivative describes how a function changes at a specific point.
Hello, my name is Denise, and I will explain the different parts of the derivative definition and how this concept is interpreted mathematically.
And I am Monse. I will finish with the formal definition, the derivative theorem, and the importance and application of derivative rules. We hope you enjoyed this presentation and learn something new about calculus. Thank you.
Definition of a derivative. The derivative is a fundamental tool in calculus used to understand how things change. At its core, the derivative measures how a function behaves at a very specific point. Imagine you're driving a car, your speedometer tells you your destination speed. That is how fast you are going right now, not over the last hour or the last minute. This idea of instantaneous change is exactly what a derivative describes. In mathematics, when we look at the graph, the derivative gives us the shape of the tangent line at a single point. A tangent line is a line that touches the curve at only one point, without crossing it. The steepness of that line represents the derivative. The derivative answers questions like how fast is a quantity increasing? How fast is it decreasing? How sensitive is an output to change in the input? This makes the derivative essential in physics, economics, medicine, biology, chemistry, engineering, and many other fields. Now that we understand the general idea behind a derivative, let's explore the parts of its mathematical definition.
Let's go to the parts of the derivative theorem. There are so many, so I can explain the difference and their definition. So one constant rule is a function is a constant value, its derivative is zero. This makes sense because constants do not change. The constants is it could be any one number like 1 or 2. This is why the constant rule is means that it's zero. So let's go to the 2, that is the power rule, one of the most important rules. This rules is using constantly calculus. This rule defines d over dx multiply x exponent n equal nx n minus 1. And the 3 rule is constant multiply rule. If you multiply a function by a constant, the derivative keeps that constant. So the rule that could be a relationship to the rule 1, the constant, but this is a function by a constant. The fourth rule seems like the sum rule or the plus rule. The derivative of the sum plus is the sum of the derivative. That means is the f plus g derivative equal f the derivative minus g derivative. The fifth rule says that product rule. This rule is used when two functions are multiplied. This rule is essential when dealing with functions that are not simple. This rule says that parentheses f plus g parentheses derivative equal f derivative plus g derivative for g. That is easy to learn because next to the equal, see the derivative of the first function. So let's go to the quotation rule. That is the rule to use it for division of function. That means that the rule to this is f over g derivative, that is equal to f derivative multiplied to g minus f multiplied to g derivation over g to 2 exponential. That is too easy to learn that because it's similar to the product to the rule. So the seventh rule is chain rule. This rule is used for computation function inside other function. The chain rule is one of the most powerful tools in calculus if you have a function inside other function. That is the old theorems in calculus. There are more, but this is one of the most important in calculus. So the importance of this is that to you how to use it in derivative function. No matter if you don't learn it, if you don't remember it, but if you how to use it, that is important. So there is the theorem of derivative.
Formal definition. The complete limit definition of the derivative is going to be shown in the screen. This formula shows exactly how the derivative is constructed. We take 2 points on the function, one at x and one at x plus h. We calculate the average rate of change between them. Then we ring of values of h so that the 2 points get extremely close. Is the limit, the average rate becomes the instantaneous rate. This definition is essential for understanding the meaning of derivatives, but using it for every calculation will be very slow. For this reason, mathematicians developed a set of rules known as derivative theorem that make finding derivatives much faster.
Derivative theorem. The derivative theorem refers to the collection of rules that allow us to compute derivatives easily, instead of using the limit definition every time. We can apply formulas that simplify the process. These rules include power rule. The power rule says that to differentiate x to the n, you multiply by the exponent and subtract 1 from it. Constant rule. The constant rule says that the derivative of any constant number is 0. Product rule. The product rule says that to differentiate two functions multiplied together, you differentiate one and keep the other, then switch. Quotient rule. The quotient rule says bottom times derivative of top minus top times derivative of bottom over bottom squared. Chain rule. The chain rule is used when one function is inside another. Differentiate the outside, then multiply by the derivative of the inside.
Thanks to these rules, we can differentiate complex functions efficiently, which is extremely useful in physics, chemistry, biology, economics, and many other areas.
Importance and application. The derivative theorem is incredibly important because it transforms the derivative from a complicated limit expression into a practical, usable tool. Applications include physics, velocity, acceleration, and force, biology, population growth rates, chemistry, reaction rates, economics, cost, renew, elasticity, engineering, optimization of designs and materials, everyday life, speed, slopes, change in temperature, and more. Without derivative rules, modern science will be more difficult. After that, we got into a conclusion and then we are going to present it.
In this presentation, we learned that the derivative describes how a function changes at a specific point.
The conclusion is we explored the parts of the derivative definition, including the limit process and the difference quotation.
And finally, we discussed the derivative theorem which allows to compute derivatives quickly using rules. Together, these ideas form foundation of differential calculus. Thank you for watching and thank you, teacher Chaparrito.
En esta ocasión vamos a resolver tres ejercicios de derivadas. El primero nos dice que tenemos una función f de x igual a 4 dividido entre x elevado a la menos 3. Como primer paso, podemos simplificar o hacer ver un poquito más fácil nuestra función. Esto sería lo mismo que tener 4 que multiplica. Tenemos x a la menos 3 en el denominador. Si lo queremos subir al numerador, nuestro exponente pasa a ser signo positivo. En este caso sería x elevado al cubo. 4x cúbica. Ahora sí, pasamos a hacer nuestra derivada. F' de x va a ser igual a... ¿Qué regla aplicaríamos en este caso? Tenemos una regla que nos dice que y igual a x a la n, su derivada va a ser igual a n por x a la n menos 1. Okay. ¿Qué valor de n tenemos en este caso? N es igual a 3. Ok, entonces ahora sí sería 4 que multiplica al valor de n. Nuestra n ya dijimos que es 3. Que multiplica a x y se le resta una unidad a nuestro exponente. 3 menos 1. Por último, nuestra derivada de x va a ser igual a 4 por 3, 12. X, 3 menos 1, 2. Bueno, ahora el ejercicio 2 nos dice que tenemos una función de x igual a 4 dividido entre 5x cuadrada. Hacemos el mismo procedimiento. Nuestra x cuadrada la vamos a llevar al numerador. 4 quintos de x a la menos 2. Ok, nuestra función derivada va a ser igual. Aquí, ¿qué valor de n tenemos? N igual a menos 2. Ojo con el menos 2. Tenemos 4 quintos que multiplica al valor de n menos 2 que multiplica a x. N menos 2 y le restamos una unidad. Esto va a ser igual 4 quintos por menos 2 sería 4 por 2, 8. Más por menos, menos 8 quintos, mismo x, menos 2, menos 1, menos 3. F' de x va a ser igual a menos, tenemos x elevado a menos 3, lo podemos regresar al denominador para que menos 3 nos cambie ahora al signo positivo. Sería 8 entre 5x al cubo. Esa sería nuestra respuesta. Para el tercer ejercicio, tenemos una función de x igual a x cuadrada menos 4, x más 2. Tenemos un binomio conjugado. Esto sería x más 2 por x menos 2. Recuerden, con un binomio conjugado, los signos contrarios y los mismos valores nos eliminan el término bx. En este caso, solo tenemos x cuadrada menos 4, dividido entre x más 2. Podemos cancelar este término con este término y nos queda x menos 2. Ahora sí, nuestra función derivada va a ser igual. Derivada de x, 1, derivada de menos 2 es 0. Y esta sería la respuesta.